Now, today we will talk about sigma notation. Now, the main idea for today's lesson is that we use sigma notation, which this is the symbol that we're going to use to represent sigma notation. When we talk about sigma notation, we need to start thinking about summation or to add. When we talk about sigma notation, start thinking about summation, which is just adding. We're going to be adding some expressions over and over again from a starting point to an ending point. And we're going to use this symbol, which is called the sigma notation, to represent that idea. So when you see sigma notation, start thinking about addition or summation. So let's see some examples. Now, here, again, this is the sigma notation. And the sigma notation, it's always going to be composed of three things. An expression that is always going to be in the front. This expression is the expression that we're going to be using as to what to start summing. So like I mentioned on the main idea, we're going to be summing expressions. You need to have a starting point and an ending point. What's in front? It's what we're going to be adding over and over again. This expression is the expression that we're going to be adding over and over again. Your starting point, it's always going to be underneath the sigma notation, and your ending point, it's what's going to be on top of the sigma notation. So again, you only need to be paying attention to three things, which is the expression in front of the sigma notation, which is what we're going to be adding. The number below is where are you going to start adding, and the number on top is where you're going to stop adding. Expression that we're going to be using, starting point below, ending point above. So now that we have a small introduction to it, let's try to do some examples here. Let's look at the following. Here, they're asking us to evaluate the following. They're asking us to add the following. Now notice that here, the expression that I'm going to be adding is n. So if I want to actually evaluate the following expression, I'm going to be substituting numbers into this expression. The first number that we're going to be substituting with is 1, because again, underneath the sigma notation, this is where you're going to be starting. So we're going to start at 1, and we're going to plug it into the formula or the expression in front of the sigma. So here, we're going to plug in 1. Then again, you're going to be adding. What's the next number after 1? That's 2. So now 2, we're going to plug it into this expression, which is just going to give me 2. And I'm going to add the following. 3 is the next. Plug it in, so we have 3. And then you're going to have 4. And then you're going to have 5. And we're going to stop there, because this is telling you substitute these values to this expression until you reach 5, which is kind of like what we have here. So the last thing that I want to do is just add those values. So that means that this sigma notation is equals to 1 to 2, so that's 3, that's 6, 7, 8, 9, 10, so that's 15. So that means that the final answer for this sigma notation is just 15. Again, sigma notation, you're going to be adding. You're going to be adding this expression over and over again, but each of those terms is going to have a substitute where you're always going to start at the bottom and stop at the top. Let's look at example 2. Now notice here that the expression, it's a little bit different. It's not as straightforward as the first example, but you will see a small difference here. Again, the expression in front is what you're going to be substituting it to. Your starting point and your ending point. So now let's evaluate the following. So we're going to have first parenthesis is going to be 50 minus m is the thing that's going to be changing from term to term. So the first thing I'm going to be substituting is 1. close parenthesis. So notice that this is the first term that I'm going to substitute it by. Now I need to substitute it again, but now this time I'm going to use the next number, which is 2. So now I'm going to have 50 minus, but now this time I'm going to substitute 2 plus, I'm going to reach the next number, which is 3. So now I'm going to have 50 minus, and notice that in red, those are the numbers that I'm going to keep substituting with. The 50 does not change because in your original expression here, 50 stays as a 50. The only thing that is changing is the variable that we're going to be changing here. So now the next number is 50 minus, now we got 4. And lastly, we're going to have 50, no, I guess not lastly. We're going to have 50 minus the next number, which is 5. Now we're going to stop at 5. If we go back here under sigma notation, we're going to stop all the way to 6. So I need to do this one more time. So now it's going to be, again, 50 minus the next number, which is 6. So we did the substitution okay now. So this is considered your final answer. But we got to simplify. We need to come up with a single number. So let's just evaluate each one of them, and then at the end, use our calculator to find the final answer. So 50 minus 1, that's 49. Plus 50 minus 2, so that's 48. 50 minus 3, that's 47. 50 minus 4, 46. 50 minus 5, that's 45. And 50 minus 6, that's 44. Excellent. We have those values. Let's use our calculator to find our final answer. So now we're going to have 49. That's 48. And then we got the next number, 47. Then we follow by 46. Followed by 45. And lastly, 44. So that means, oops, put an extra 4 there. So that means that our final answer is 279. This is our final answer. This is the evaluation of the sigma notation. Notice that all we did was this expression is going to be there in every term. The only thing that's going to change is your substitution to that term. And you're going to start at 1 and we're going to finish at 6. That's all we did here. It's just computation, plug it in, move on to the next term. Plug it in, move on to the next term. Plug it in. And then at the end, you just find your final answer by evaluating using your calculator. Let's look at a last example here. Okay, so this is what we have now. Let's identify here. This is the expression that I'm going to be substituting it with. Now this time, I'm going to start at 4 and I'm going to end at 9. So let's get started. So now again, the 20 is not going to change. The only thing that's going to be changing from expression to expression is just that A, because it tells you right here, A is the only thing that's going to be changing. We start at 4 and we finish at 9. So let's write that out. So now we're going to have 20 minus 4 is the first thing that I'm going to be substituting. So to the second does not change because notice that the only thing that is changing is just the A. Everything that is in that whole expression remains the same. So now we're going to move to the next term, which is going to be 20 minus. Now we're going to minus the next, which is 5 to the second. Move on to the next one. Then we got 20 minus 6 to the second. And then we're going to just repeat this process. But in every single term, we need to change the value for A. So 7 is the next one, plus, we're almost there, 8 to the second, plus, again, we need to pay attention as to where are you finishing. And the number that's on top of the sigma notation, it's what's going to tell you what's the last term that we're going to be substituting it to. So notice here that we're done. We have the expression. It got repeated every time, and in every single term, a changes value, and we started at 4 and we finish at 9. So this is our final answer. So now what we have to do, we're just going to use our calculator to figure out what this is. I like to do just one parenthesis at a time. So 4 to the second. So the first term is just 4. Now let's figure out the second term, which is going to be, there's no need for the parentheses. So we got 20 minus 5 to the second. So we got negative 5 now. Then we're going to figure out the next term, 20. So we got 20 minus 6 to the second. So we got minus 16 now. Just give me a second here. Minus 16 now. Move on to the next one, which is when we have 7. So 20 minus 7 now. 7 to the second. So that's minus 29. Follow with 20 minus 8 to the second. So minus 44. And lastly, 20 minus 9 to the second. All right, so we evaluate each one of those expressions. So now our last step is just figure out what this is, put it in the calculator. So we got 4, you take away 5, then you take away 16, and then you take away 29, and then you take away 44, and then you take away 61. So that means that the evaluation for the sigma notation, or just the summation in general, for example 3, it's negative 151. And this is how you evaluate expressions using sigma notation. So now, here's your entrance ticket. Just evaluate the following.